My name is Peter Sleesmith. I'm a chartered engineer and have 30 years' experience working with SME product manufacturing companies in the materials handling sector. The goal of this presentation is to demonstrate some of the problems faced by engineer-to-order companies and how Agile manufacturing approach can address many of these issues. This is the story of a company based in the UK that designs and manufactures pneumatic conveying systems for many different industries. The company employs about 100 people and has a range of industrial machinery products which it sells either as standalone machines or as part of larger integrated systems. The company uses an engineer-to-order production model to manage their projects. The structure of the company is typical for many engineer-to-order businesses. First point of contact for a customer would be the sales manager. The sales team are supported by sales support engineers to help generate customer quotations. After receiving an inquiry, the sales team develop a solution for the customer. The solution would often be a joint effort, combining the knowledge and skills of several experts from around the company. Several different scenarios are looked at, each one requiring research and separate technical layouts and costings. The sales team then use generic information and previous project examples to base their quotations and send relevant details to their clients. This process takes considerable time, particularly when information is required from the engineers who are likely to be busy on other projects. Next, the finance department must check and approve all the customer quotations to ensure profitability targets can be achieved. The finance team insist upon including several contingencies due to the historical underestimation of projects. This makes it difficult on occasions for the sales team to provide competitive prices to their customers. Many inquiries are prepared, but the company is only ever successful with a handful of these. However, eventually a purchase order is received. A sales handover meeting is arranged and attended by representatives from each department. Attending the meeting would be sales, finance, projects, engineering and production. The purpose of the handover is to transfer responsibility for the project from sales to the operations team. The operations team carefully studied the customer order and supporting documents. The team raised questions and sometimes sales have the answers, but some ambiguity remains. Often there is an understandable reluctance from the operations team to accept responsibility for the project while some of these questions remain unanswered. As is typical for many engineer-to-order projects, there are many uncertainties and assumptions at this stage. It is difficult for the operations team to be confident that the project will be completed within the timescale and the cost that's been approved by management. The project is just one of many live projects. The project manager is personally responsible for 4 projects, and the engineering team has 20 projects on the go at different stages of completion. The project incorporates many of the company's standard products. The expression standard is used loosely here because these products lack many of the characteristics generally associated with the term standard. The project manager goes on to allocate a work breakdown structure to the project. This provides a framework for specialist engineers to complete their design specifications. In the work breakdown structure, the assumptions and estimates provided by sales indicate an estimated time for engineering to complete and a budget allocated for manufacturing. A high priority for the project manager is to release purchase orders for the long lead components. Without progressing these items immediately, the project delivery date is not achievable. The engineering manager, responsible for managing the engineer's work schedules, attempts to balance the workload for all of his projects. Sometimes this is impossible, and it is necessary to discuss compromises with the project managers. Eventually, the design engineer's work schedules do allow them to look at the new project. The engineer raises further questions, which need answering and point out problems in the design to the project manager. The design engineer focuses on both the overall design and the equipment used within the system. Much of this equipment consists of standard equipment. The design engineer looks through a list of previous projects and selects one that offers some of the features required by the current project. The design engineer uses this as a starting point for the system and the product design. The design engineer prepares a draft layout of the overall system, and the project manager sends this to her client to allow the client's other work to progress. Currently, the procurement and production team are unable to progress their work as they're waiting for the final design from engineering. Several weeks into the project, the design engineer has prepared a more detailed layout of the system and has identified and modified several standard products. The project manager is happy that the project is going to plan and the engineering has only used the allocated time. The project manager then receives a concerned email from the customer. The system must change as the space required is allocated to other equipment. The change required has a significant impact on the overall design and the standard products which are now near to completion. The project manager has no choice and places the project on hold. Following the delay, the design engineer has moved on to another project and is now not available for 2 weeks. Delivery is now affected. The project manager informs the customer that the changes delay the project by several weeks. The customer is not happy and informs the project manager that the change is only required because the information sent to him originally by the sales team was inaccurate. The project manager decides to focus on completing the project as smoothly as possible, wanting to diffuse a deteriorating relationship with her client. 2 weeks later, the design engineer restarts the work on the project and runs into several more problems resulting from the changes. The rework takes several weeks and changes some of the long lead components. The replacement of these components causes the delivery to slip by another 6 weeks. Production is instructed to make up as much time as possible by outsourcing and using overtime in the factory. The project is now liable to late delivery penalties. Production have not yet started the work and yet the project is already late. The delay has cost the company a great deal of additional time and money, replacing the long lead components and fast-tracking production. The additional work has a knock-on effect on other projects using the same engineering resources. The customer is unhappy and is questioning awarding the next phase of the project to a different supplier. The next phase of the work is essential to the company to bring in much needed revenue. An internal inquiry is carried out to determine the responsibility for the overspend. Perhaps the cause was the initial information sent to the customer by sales. Perhaps the project manager should have argued the reason for the change, defending the company more robustly. Perhaps the engineering manager should have given a higher priority to provide design resources. Despite many hours analysing the project, the responsibility remains unclear. Each department pointing fingers. There are no lessons learned, no changes to policy or process to be implemented. A different approach. If the company had adopted an agile model for producing the standard products within the overall engineer-to-order project, the outcome of the project could have been very different. The standard products are modular and provide millions of configurable options. Behind each selection is a wealth of useful information, accurate drawings and costs ready-made and awaiting use. The engineer-to-order production model can be adapted to include the configure-to-order products. Now we'll see how the Agile model can significantly improve product selection and the overall success of the project. By using configurable standard products, the sales team quickly compare the technical and commercial benefits of each alternative. A product configurator guides the sales support engineer to make selections. Within minutes, the sales support engineer can see a 3D model of the proposed product, together with accurate costs. Comparisons between the different product combinations is achieved quickly and accurately. The sales team focus their attention on the broader system and how the system can add value to their client. A proposal is generated automatically by pressing a button. The product configurator doesn't prepare the details of the overall system, but it provides much of the detailed content. The product configurator has now saved between 50 and 60% of the time required to quote the system. The configurable products provide the sales team with quality information. They are now more self-sufficient in finding technical solutions for themselves. Product information is available immediately without having to search for it. A financial summary has been prepared automatically and emailed directly to the finance department for approval. The finance department no longer require the cost contingencies for the standard products, so the price is now more competitive. The quotation arrives quickly in the client's inbox before the competition. The customer is delighted to receive the detailed proposal so quickly. Providing accurate details, drawings and 3D models, the company is more likely to be awarded the project. The customer can start planning the integration of the new system much earlier than expected. Sales handover attended by each department is now much shorter. Engineering recognise all the standard products used in the system as they've been responsible for the tools used to configure the products in the first place. The standard products require no further engineering and are sufficiently detailed to pass directly to production. However, the project manager chooses not to release the products until she has had some feedback from her client. The work breakdown structure is considerably simplified. In place of the deep and complex tasks required to engineer and define the standard products, these sections now refer to a single part number. The client contacts the project manager to notify her of the change. Some of the equipment would not fit as intended. The project manager informs the client that the engineer has already started to prepare a solution. Some of the standard products have needed to be reconfigured, however this takes just a few minutes to complete. The technical details are available immediately with the revised costs. Some of the long lead items have had to be changed, however because the problem has been caught very early on in the project, it is possible to adapt these with a minimal additional cost. The project manager explains to her client that engineering has found a solution and she's been able to keep the additional cost variation to a minimum. There is now no dispute over the quality of information provided at the sales stage, which was informative and detailed. The client is pleased to authorise the additional price of the variation and an extension of 2 weeks. The production department has been reviewing the standard product information for several weeks now. Their production schedules are prepared and they can start production as soon as the project manager has given them the go-ahead. Delivery of the project is on time. The project makes the budget margin and the company is awarded the second phase of the project. Agile manufacturing is not a term usually associated with engineer-to-order business. However, in our story, Agile methods were employed successfully alongside engineer-to-order structures for the project. Sales benefited from being able to access the modular products, which allowed them to optimize a solution and provide their customer quickly with better quality information. This increased their competitive position and saved cost. Information was shared across the company, so transfer was seamless. When a change did occur, products could be easily and quickly reconfigured. Handling change quickly reduced the impact on both the customer and the company. Risk was removed from the project at every stage. Sales provided information which was not ambiguous. Management were happy that costs were accurate. Engineering and production had fewer delays and bottlenecks. Whilst modular product design and configuration is just one part of Agile manufacturing, I hope that this story demonstrates that applying Agile to complex engineer-to-order projects can help reduce time, save cost, and eliminate errors. Gatehouse Design are leading experts in product standardization, modular design, product configuration, and design automation. We're always willing to help and offer advice.